Hello, and welcome to the Soils and Engineering Laboratory of the Department of Geology and Environmental Science, James Madison University. I'm Professor Scott Eaton, and this short video demonstrates the procedure for the Standard Proctor Compaction Test. For this experiment, you'll need a standard compaction mold, 1/30th cubic foot, and a standard Proctor hammer, 5.5 pounds. Pre-weighed moisture tins, 2 balances, one for the moisture tins and one for the bulk soil sample, a large mixing bin, tray for drying soil, a steel straight edge, tap water and graduated cylinders, brushes, knives and spoons, dustpans and cleanup brush, cloth rags, data sheets, fill book and pencil. Be sure to pre-weigh your tins before starting your experiments. On average, it will take you 6 tins per run on the Proctor mold. Obtain about 6 pounds of air-dried soil that has passed the number 4 sieve on which the compaction is to be conducted. Add enough water to the soil and mix it in thoroughly to bring the moisture content up to about 5%. As we are using a sandy soil, and from previous knowledge, we will start with our procedure with 200 milligrams of water. Determine the weight of the Proctor mold and the base plate using the scale at depth for large weights. Do not include the extension collar with your measurement. Be sure you are using the scale that can handle a large mass. Many scales of the past have been destroyed by operator carelessness. Be sure you know the maximum weight of your scale and proceed with caution. If you have doubts, contact your instructor. Record the value of your weight. When you've recorded your value, reattach the collar to the top of the mold. Easier than others. Place the mold on the floor or equally solid surface. Do not use a table or lab bench for these next procedures that include compacting the soil. Spoon the moist soil into the mold in 3 equal layers or lifts. Each lift should be compacted uniformly by the Standard Proctor hammer 25 times in a clockwise or counterclockwise motion. Notice the rotational motion that covers the entire surface area. Retighten the collar if needed, and spoon in some more soil to roughly 2/3 from the bottom to the top, full. Continue the procedure with 25 blows from the hammer, going in a clockwise or counterclockwise position. For your third and final lift, add soil to nearly the top of the collar, as its volume will reduce significantly from the compaction, and we want to ensure that at the end of this compaction, the soil mass should be and should extend above the contact seam between the mold and the collar. Proceed with 25 blows of the hammer in a clockwise or counterclockwise fashion. return the mold to your workbench for the next procedure. Place the mold inside a bin or tray to catch excess soil that will be removed from this next procedure. Remove the collar from the mold by loosening the wing nuts in a gentle twist of approximately a quarter turn in slow extraction. Be careful not to break off any of the compacted soil inside the mold while removing this collar. Using a straight edge, trim the excess soil above the mold with multiple shallow passes. Continue the shaving process until the top of the compacted soil is even to the top of the mold. If divots of soil are accidentally plucked from the beveled surface, gently patch these divots, pressing firmly to refill the void. Retrim if necessary. Using utensils, remove any lingering soil that clings to the outside of the mold, including crevices that may be hard to reach. It's time to weigh your mold and compacted soil on the proper scale. Determine the weight of the combined mold and compacted soil and record its value. It's time to extract a moisture sample from the compacted soil. Taking a large spoon or knife, dig approximately 1/3 to 1/2 into the core of the compacted soil and take a small sample for a moisture content. Place this sample into one of your pre-weighed tins. Place the remaining soil back into your soil bin for further runs. Clean off your mold for reassembly for your next run. Remove the remainder of the soil from the mold and remix it with the leftover soil in the pan. Add another 100 milliliters of water for a second round of testing, thoroughly mixing the water through your soil. Run your experiment again as outlined earlier, recording your weights of the mold soil apparatus and the sample of the moisture content calculation. Repeat this procedure for a third, fourth, fifth, and perhaps sixth time, adding 60 milliliters of additional water each run. This is approximately increasing the moisture content by 2% each time. Be sure to place all 5, 6, or 7, or whatever the number is of your moisture content tins into the oven with the lids off for at least 24 hours prior to reweighing them for water content. When you have completed all of your tasks, take your wet soil and spread it across multiple trays to help accelerate evaporation and to make them readily available for the next student's use. Please note that the ASTM procedure prohibits the recycling of soils, as the clay fraction frequently retains some of the residual compaction from previous tests and can give a false value of compaction. As we are working with a sandy soil for this experiment, most of the compaction occurs from the rearrangement of the grains rather than from a reduction of particle size. That is, plastic deformation, as can happen with clays. Be sure to leave your workspace as good or better than you found it, particularly the floor. Wash and dry your equipment and return them to their proper location. I hope you've enjoyed watching this video and that it was helpful in guiding you through the Standard Proctor Test procedures. Be sure to carefully follow your instructor's guidelines, and when in doubt, refer to the original ASTM procedure, designation D-698-07 for this test. Thanks for watching.